All right, this is probably the hardest example I have for you today. So, Marla needs to find the height of a building. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74 degrees, or 74.2 degrees. Okay, so we have a building. We are going to assume it makes a right angle with the ground. Okay. From a point on the ground, angle of elevation, we talked about that in the last section. What does an angle of elevation mean? There's up or down, right? Elevation and depression. Elevation is going up, depression is going down. The thing is, they both start at a horizontal line. Okay, I already told you we're starting from this point on the ground, so the angle of elevation, that's just the angle coming up here. So if I were to make this into a triangle, I know this is 74.2 degrees. She then walks back 35 feet. So this distance here is 35. From the second point, the angle of elevation. So I'm still standing on the ground, measuring distance to the top. This angle is 51 degrees, or 51.8 degrees. Find the height of the building. All right, so this is very similar, like on our homework question number 5, the first one on the back side had a triangle very similar to this and asked you to find something. We're trying to find how tall my building is, x. Now our trig functions only work in right triangles. How many right triangles do we have here? 2. Okay, you don't have to draw them separate, but if it helps you visualize it, we have this first one where we are looking for that. We had this angle. And then once we backed up, we had a new one. This changed. Okay. Do I know any sides in my triangle? No. Let's come down here, because I did have a little bit of information with that 35 feet, so let's call this maybe y. What would be the bottom in the second triangle? Good. All right. Between the two of them, I think we have enough information we can find x. So let's start with this first triangle. X is across from it, so that's the opposite. Y is touching it, not the hypotenuse, so that's our adjacent. So what trig function involves opposite and adjacent? So we could say the tangent of 74.2 degrees equals x over y. All right, I can multiply over my y, but I'm pretty well stuck at this point. Do you remember doing a question like this in the last section? We did it that last day, and I said, I'm not going to give you any like it yet. We're working towards it. Let's come to this triangle. X is also opposite. This side is still adjacent, so we can do tangent in the second triangle. So the tangent of 51.8 degrees equals x over y plus 35. Okay, I still don't know x or y, so how is this helpful? Okay, they're equal to the same thing, so what we're going to do now is set them equal to each other. I'm going to go ahead and distribute this tangent. So that would be y tangent of 51.8 degrees plus 35 tangent of 51.8 degrees. All right, now what? these have y, so we need to get them together. All right, would it confuse you guys if I subtracted it over and factored out the y on the same step? So I'm just going to put the y in front, and then I'd be left with the tangent of 72.4 degrees minus the tangent of 51.8.
It's 72, I mean, 74.2.
Oh, thank you. Flipped it right there, didn't I? Okay. It's fairly complex, but we are actually pretty much to our answer. You have y times something. So to get it by itself, we are going to divide. And then we're just going to put this whole thing in our calculator. Now I am going to ask, I want all of you to try plugging it in so that if you're having a calculator error, we fix it. I think it's very useful to view this as a fraction as you're putting it in. Also, make sure you're in degree mode. Remember, every time you push tangent, it opens a parenthesis, so you have to close it. What were we asked to find in this problem? The height of the building. That was x. But we really have it because, remember up here, we said x is just y, so my 19.6527 times the tangent of 74.2 degrees. So I'm just going to plug my y in to find out what x is. Let's go ahead and give our final answer in significant digits. We had, so my angles were 3, but 35 feet, that's only 2. So we'll round to 2 significant digits. So we get 69.45, so that would be 69 feet for the height of the building. I know that problem's long, okay? I'm not going to deny that. That is the most complicated problem I will give you. Are there any questions? So what I'm going to do is just practice. I think we have, what, 3 or 4 examples left, so we'll finish those and then have time to work on that handout. All right. The 2 equal sides of an isosceles triangle. What does isosceles mean? 2 sides are the same. So here's my isosceles triangle. Let's say these are the same. Did I say it was a right triangle? No, so we can't make that assumption. So the 2 equal sides are each 24 centimeters. If each of the 2 equal angles measures 52, so these angles down here are the same, they're both 52 degrees. I want the length of the base and the altitude. The base is the bottom, so I'm just going to call that B. What's the altitude? The height. Okay, so I'm going to call that A. What kind of angle does that form with the ground? So, the whole thing isn't a right triangle. But if I just look right here, this is. Can we find A? So, 24 is across from the right angle, that's the hypotenuse. A isn't touching my angle, so that's the opposite. What trig function involves opposite and hypotenuse? So the sine of 52 degrees equals A over 24. We multiply our 24 and we had two significant digits in the problem. So we get 18.9123, so that would be 19 centimeters. Let's talk about the base, that's the bottom. When I look right here, this isn't the whole base. Let's just call it x for a second. Can we find x? So that would be my adjacent side. So what trig function? So the cosine of 52 degrees equals my adjacent x over my hypotenuse 24. So I get it's 14.7759. How do I get the base from that? That was half, so take that number times 2. We get 29.55, so we'll have to round that up to 30 centimeters for the base.
Could you also get x with Pythagoras' theorem?
Yes, once you have two sides, you could do Pythagorean theorem to get the third, absolutely. Any questions on that one? All right, take a second and see if you can draw this picture and label your information. Pictures look good. And I'm very happy to say I didn't see anyone put the shadow on the hypotenuse. So you guys are like the first class ever that knows your shadow goes on the ground. So congratulations, I'm very proud of you all. So we know this is 75 feet, shadow down here, 43 feet. Okay, we want angle of elevation, so that's from the bottom up. So we are looking for this angle. So this would be my opposite side. This would be my adjacent side. So what trig function? Tangent. We'll say the tangent. I don't know my angle. I'll just call it theta for a minute. Equals opposite over adjacent. How did we find those angles?
Tangent -1.
Remember that second tangent on your calculator? All right, and for extra fun, I said to the nearest 10 minutes. So when I put this in, I get 60.1729 and some more decimals. So that's 60 degrees. How do I get my minutes? Right, 0.1729 times 60, which gives me 10.3, so 10 minutes. Any questions there? Why don't you guys see if you can do the next question on your own? So an escalator, taking people upstairs, so that's the hypotenuse. We want to know how long it is, so that's our x. It makes an angle of 33 degrees with the floor, so the floor is down here, and carries people a vertical distance of 21 feet. So this would be my hypotenuse because it's crossing the right angle. 21 doesn't touch my angle, so that's opposite. Opposite and hypotenuse is sine. So sine of 33 degrees equals 21 over x. You can multiply your x over. Divide by the sine of 33 degrees. 21 divided by the sine of 33. Gives us 38.5576, or we had two significant digits, so it'd be 39 feet. Is that okay? So the hardest part is drawing your picture and putting your information in the right spot. Last one. A man climbs 213 meters up the side of a pyramid. So what shape should I draw? Triangle. Do I know that it's a right triangle? No, probably not. So, he went 213 meters up the side. And finds the angle of depression. Angle of depression is from a horizontal down. So he climbed up, we're at the top. If I want an angle of depression, I have to draw in a horizontal line here. So from there down, my angle is 52.6 degrees. How high off the ground is he? So I'm looking for this height. All right, there's different ways we could go about setting this up. This would make a right angle. We need at least one angle in our triangle, so how could I find one? Okay. So there at the top, we know these would make a right angle, so if you find the complement, it's 37.4 degrees. So then, this would be our hypotenuse because it's across from the right angle. This would be adjacent because it touches our angle. Adjacent and hypotenuse is cosine. So multiply to 213. So 169.2, so 169 meters.